tools. For instance, use CS50.io. IO sort of connotes input output. It actually is belongs though to a small island nation, a country whose country code is .io. And you see other 2-letter top-level domains that are country-specific indeed. Something.uk, something.jp, and the like typically refer to countries. But some of them have been rather co-opted. .tv as well, because they have these meanings in English as well. Lastly, this is what we'll call the protocol. That specifies how the server uses this. URL to get data from point A to point B. So what is inside of this envelope? Let's now start poking around a little bit more. What is inside of this envelope? It's essentially, for our purposes today, one of 2 verbs, either get or post. And if any of you have dabbled with HTML or made your own website, you might have seen some of these terms before. But these 2 verbs describe just how to send information from you to the server. Long story short, more on this next week. Get means put any user input in the URL. Post means hide it so that things you're searching for, credit card numbers you're typing in, usernames and passwords you're inputting don't show up in the URL and are therefore visible to anyone with access to your computer and your search history, but rather they're somehow provided elsewhere deeper into that envelope. But for now, we'll focus almost entirely on get, which is perhaps the most common one that we're always going to use. And what we're going to do is this. Let me switch over just to a blank screen here. And if we assume that little old me is this laptop here, and I'm connected to the cloud, and in that cloud is some server that I want to request the web page of, harvard.edu or yale.edu, it's really going to be a 2-step process. There's going to be a request that goes from point A to point B. And then hopefully the server that hears that request is going to reply with what we'll typically call a response. And other terms that are relevant here is my laptop is the so-called client. Harvard.edu, Yale.edu, whatever it is the so-called server. And just like in a restaurant where you might request something to eat, the server might bring it to you. It's, again, that kind of bi-directional relationship. One request, one response for each such web page we request. All right, so what's inside these envelopes and what do we actually see? Well, this arrow, this line I just drew from left to right, representing the request, technically looks a little more like this. When you visit a web page using your browser, on your phone, laptop, or desktop, what's going inside that envelope and the textual message your Mac or PC or phone is automatically generating looks a little something like this. The verb get, the URL, or rather the path that you want to get. / represents the default page on the website. HTTP/1.1 is just some mention of what version of HTTP you're speaking. Now we're up to versions 2 and version 3, but 1.1 is quite common. And the envelope contains some mention of the host that was typed in, the fully qualified domain name. This is because single servers can actually host many different websites. If you're using Squarespace or Wix or one of these popular hosting websites nowadays, you don't get your own personal server most likely. You're on the same server as dozens, hundreds of other customers. But when your customers, your users, browsers include a little mention of your specific fully qualified domain name in the envelope, Squarespace and Wix just know to send it to your web page or my web page or some other customer altogether. ... There's some other stuff there, but that's really the essence of what's in these requests. Hopefully then, when your browser requests this web page from the server, what comes back? Well, hopefully a response that looks like this. HTTP/1.1, so the same version, some status code, like a number 200, and then literally a short phrase like OK, which means exactly that, like OK, this request was satisfied. Then it contains some other information, like the type of content that's coming back. And we'll see that this too is standardized. Text/HTML means here comes some HTML, which is just a text language. It could instead be image/JPEG, or image/ping, or video/MP4. There are these different content types, otherwise known as MIME types, that uniquely identify types of files that come back. Similar in spirit to file extensions, but a little more standardized this way. Then there's some more stuff, ... But in general, what you see here are our familiar pattern, keys and values. These keys and values are otherwise known as HTTP headers. And your browser has been sending these every time you visit a website. And indeed, we can see this right now ourselves. Let me go over in just a second to Chrome on my computer, though you can do this kind of thing with most any browser today. Let me go ahead and now open up Chrome here. And let me go ahead and do this. I'll go ahead and visit http://harvard.edu, enter. And voila, I'm at Harvard's homepage for today. The content often changes, but this is what it looks like right now. Well, I typed in the URL, but notice it changed a little bit. It actually sent me to HTTPS, and it added www, even though I didn't type that. But it turns out we can poke around at what my browser is actually doing. Let me open another page, and I'm going to start to use incognito mode this time, not because I care that people know I'm visiting harvard.edu, but because it throws away any history that I just did so that every request is going to look like a brand new one. And that's just useful diagnostically, because we're always going to see fresh information. My browser's not going to remember what I previously already requested. But I'm going to go up to View, Developer Tools, which is something that all of you have if you use Chrome. And there's something analogous for Firefox and Edge and Safari and other browsers. Developer Tools is going to open up these tabs down here. I don't really care what's new, so I'm going to close the bottom thing there. And I'm going to hover over the Network tab for just a moment. And now I'm going to go and say http://harvard.edu, so the shorter version. I'm going to hit Enter. And a whole bunch of stuff just flew across the screen. And it's still coming in. And if I zoom in down here, my God, visiting harvard.edu, still going, is downloading, what, 17, 18, 19 megabytes, 20 megabytes, millions of bytes of information over 111 HTTP requests. In other words, a bit of a simplification, but my browser, unbeknownst to me, sent one envelope initially with the request. Then the server said, OK, by the way, there's 110 other things you need, 112 other things you need to get. So my computer went back and forth requesting even more content for me. Why? Well, inside of Harvard's web page is a whole bunch of images and maybe sound files and videos and other stuff that all need to be downloaded and to compose what is ultimately the web page. But I don't care about like 100 plus of these things. Let's focus on the very first one first. The very first request I sent was up here. And I'm going to click on this row under the Network tab. And then I'm going to see a bit of diagnostic information. To an average person using the web, they needn't care about this, just as you probably didn't care about it until right now. And even then, perhaps not. But if I scroll down to request headers, you will see if I click View Source, literally everything that was in the request, my Mac just sent to harvard.edu. Two of the lines are familiar. Get/HTTP 1.1, host:/harvard.edu, and then other stuff that for now is not that interesting for us. But let's look at the response that came back from the server. I'm going to scroll up now and see response headers, view source. And this is interesting. It is not OK. There's no 200. There's no word OK. Curiously, harvard.edu has moved permanently. What does that mean? Well, there's a whole bunch of stuff here that's not that interesting for us. But this line, location, is interesting. This is an HTTP header, a standardized key-value pair that's part of the HTTP protocol, that is, conventions. And if I highlight just this one, it's telling me Harvard is not at http://harvard.edu. Harvard's website is now, and perhaps forever, at https://www.harvard.edu. So what's the value here? Probably someone at Harvard wants you to use a secure connection, so they redirected you from HTTP to HTTPS. Maybe the marketing people want you to be at www instead of just harvard.edu. Why? Just to standardize things. But there are technical reasons to use a host name and not just the raw domain name. And all this other stuff is sort of uninteresting for our purposes now, because a browser that receives a 301 response knows by design, by the definition of HTTP, to automatically redirect the user. And that's why in my browser, all of this happened in like a split second, because I didn't really know or care about all of those headers. But that's why and how I ended up at this URL here. My browser was told to go elsewhere via that new location. And the browser just followed those breadcrumbs, if you will, at which point it downloaded all of the other images and files and so forth that compose this particular page. Well, let me zoom out, and let me actually go into VS Code, if only because it's a little more pleasant to do things in just a terminal window without actually using a full-fledged browser. So now let's just use an equivalent program. It's called curl for connecting to a URL. That's going to allow me to play with websites and just see those headers without bothering to download all the images and text and so forth from the website. It's going to allow me to do something like this. Let me go ahead and run, for instance, curl -i -x get. which is just the command line arguments that says simulate a GET request textually as though you're a browser. And let's go to http://harvard.edu, enter. Now, by way of how curl works, I'm just seeing the headers. It didn't bother downloading the whole website. And you see exactly the same thing. 301 moved permanently. Location is indeed this one here. So that's kind of interesting. But let's follow it manually now. Let's now do what it's telling me to do. Let's go to the location with HTTPS and the www and hit enter. And now, what's a good sign with this output? Most of it's irrelevant. What looks good? 200, OK. That means I'm seeing, presumably, if I were using a real browser, the actual content of the web page. Looks like Harvard's version of HTTP is even newer than the one I'm using. It's using HTTP version 2, which is fine. But 200 is indeed indicative of things being OK. Well, what if I try visiting some bogus URL like harvard.edu and this file does not exist? Something completely random, probably doesn't exist, and hit enter. What do you see now that's perhaps familiar in the real world? Yeah. Yeah, error 404. All of us have seen this probably endlessly from time to time when you screw up by mistyping a URL or someone deletes the web page in question. But all that is a status code that a browser is being sent from the server that's a little clue as to what the actual problem is underneath the hood. So instead of getting back, for instance, something like OK or move permanently, what I've just gotten back quite simply is 404 not found. Well, it turns out there's other types of status codes that you'll start to see over time as you start to program for the web. 200's OK. 301 is moved permanently. 302, 304, 307 are all similar in spirit. They're related to redirecting the user from one place to another. 401, 403, unauthorized or forbidden. If you ever mess up your password or you try visiting a URL you're not supposed to look at, you might see one of these codes indicating that you just don't have authorization for it.